Welcome to University of Louisville Department of Psychiatry Grand Round. It's my great pleasure to introduce our speaker today, Dr. Kathryn Marcellus. Dr. Marcellus got her MD degree from Northeast Ohio Medical University. She joined our program in July of 2019, 6 months before the COVID pandemic. My first impression of her was that she was a serious, professional, dependable resident. Somehow I assumed she speaks Spanish, so a number of Hispanic patients were assigned to her. That was my mistake. Over the years, I saw tremendous personal growth in her. Dr. Marcellus received inpatient award as a PGY2, and then she published research articles with Dr. Al-Malik and Dr. Reski. She's about to finish her tenure as co-chief resident. She is a role model for junior residents and medical students. Today, she will talk about emotions. Without further ado, let's hear from our next generation UFL psychiatrist.
Thank you.
All right.
Thank you, Dr. Wong. That was really kind. All right. So hello, everyone. Thank you so much for joining my grand rounds today. Like Dr. Wong said, I'm Kathryn Marcellus. I'm one of the PGY4 residents at U of L. And today I'd love to talk about our emotions and how they've brought us together through history and how they're still driving us apart, unfortunately. So my objectives today are to review natural selection's influence on our cerebral development and understanding of our consciousness, compare and contrast human brain development with that of other animal species, understanding how neural pathways moderate and reinforce survival drives, behavior patterns, and emotional expression, and finally explore our biological limitations with cultural and social cohesion as our global community has quickly and exponentially expanded. So to start off, I'm going to be showing you guys a couple of pictures, and I'd like you to just briefly consider them for a minute. So how was that? That was fun, right? Especially the first picture. So those are very simple examples of the feelings that we encounter on a daily basis. I'm sure that each picture sparked certain feelings inside of you. We know these as our emotions pretty intuitively, and they not just color how we view ourselves in the context of our environment, but also how we relate to each other. We can also refer to them simply as drives, innate forces that will draw us towards things that we like, that help us survive, and away from potential threats that could get us physically or socially or emotionally killed. Back early in our history, our drives were relatively simple because life was simple at that point. We were surviving essentially as animals alongside other animals. And our primary drives and focus were to go to things that sustained us, kept us alive, and stay away from things that could kill us. Now, our modern life today is clearly very different because over thousands of years, collectively, knowledge and collaborating together, we've been able to cater our modern life to our needs, which is a huge accomplishment. No other organism on Earth has managed to do that yet. But despite all of our accomplishments, why do we still have conflict? Why is there still war, poverty, etc.? Unfortunately, though we've gained a lot of knowledge through our existence, it doesn't necessarily equate with gaining wisdom. Our food drives, our perception of threats has changed very much, but we're still not able to get along. As we've surpassed our biological limitations in an exponential amount of time, especially with the last 30 years, the advent of the internet, our ability to manipulate and adapt to the world around us is huge. But our brains, our natural selection, evolution, doesn't account for that rapid shift in time. So our cerebral development is woefully limited in comparison. And that can help explain why we still have some of this conflict today. So what can we do to help with this? Now that we've spent so much time shaping the world around us, it's time to focus back inward and see how we cognitively can accept the ways we feel, understand why they act the way they do, and how it can make us better as a result. So in our vast spectrum of emotional significance and feeling, we see how natural selection started this from the most basic fundamentals of survival and how it's grown in complexity to the nuance that we understand today. So with all that being said, let's do this. So to first understand emotions as a concept, we first have to understand our consciousness. So the Webster Dictionary very succinctly defines this as the internal knowledge or conviction, the state or fact of being mentally conscious or aware of something. Great. What does that mean? It's pretty vague, and it can sometimes make us feel like this. So a very simple way to understand consciousness is to be mindful and observe the world around you. That is consciousness. Grossly, an organism's ability to interact with its environment. And this scales from the most simple of mechanisms to the very, very complex. To further break this down, Rupert Glasgow, who was a psychologist, he published a book called Minimal Selfhood and the Origin of Consciousness. He divides this down into two further components, and these are awareness and intelligence. So awareness, strictly speaking, is an organism's ability to perceive its environment. And to do that, you need at least some understanding of your external surroundings and also a way to monitor your own internal needs and provide for your physiological drives. So at least in humans, internally, we're aware of our body's needs through electrical, chemical, hormonal signaling to the brain, which helps coordinate all of these functions. And we also have our five senses to help us perceive the world around us. So as an example of the most simple, the snail is pretty good. We don't recognize it as having any sort of self-awareness or recognition of itself, but it's still able to simply direct itself through the environment based on simple drives, going towards food or shelter, or if faced with a non-specific stimulus that could be perceived as a threat, it will automatically go to protect itself involuntarily. As life becomes more complex and we start to see the emergence of a cerebral cortex in evolution with certain birds, definitely mammals, we start to see the ability to have self-recognition, to recognize yourself as a distinct entity in your environment. In lab studies, this is most commonly shown through the mirror test, where scientists observe if an animal can recognize its own reflection compared to thinking it's just another animal like itself. Intelligence, on the other hand, is a tool that all organisms use to solve problems in the environment. So in interacting with our surroundings, we not only need to be able to direct ourselves through the environment to achieve our goals, we also have to learn to solve problems, to be able to retain information of past events, reflect on them in some way, so that we can adapt our future behavior to more positive results. So on the most simple form of this slime mold is navigating a maze to get some food. So it's aware of the food in the environment, tracking the concentration gradient of chemical signals. It's also aware of the boundaries that are preventing it from achieving that goal. So you can see that it's extending parts of itself, this slime matrix, as the most rudimentary form of memory, tracking where it's sensing these chemical signals of the food. And based on what it's perceiving, it's able to direct its energy in an efficient way to find the quickest way to solve the maze and reach its goal, feed. Complex organisms are able to further expand on this to the point where you can abstractly take an object and use it for a purpose outside of its normal natural function. So we've seen with both awareness and intelligence, consciousness as a whole, these have built upon simpler foundational structures to create the complexity that we now see. And this is largely due to natural selection, selecting for behaviors and traits, structures as a result that allow for increased survival. So two very basic theoretical models that we can use to describe this are illustrated here. Granted, disclaimer, these are relatively simple. There's newer information out there which gives us more understanding of the development of reptilian versus mammalian versus our brains. But for the purposes of this talk, we're going to use this as a very basic example. So on the left, we have Maslow's hierarchy of needs, which was conceptualized in the 1940s. And this showed how through evolution, as our most basic survival essentials were met, it allowed for further complexity in the abilities of the organisms after it, and complexity in what survival essentials look like after that. On the right, we have Paul MacLean's triune model of the human brain. And this kind of shows structurally how our brains may have evolved through co-opting simpler, more foundational structures to build the other structures of the brain on top of it and increase our ability to manipulate, adapt the world, and recognize and view ourselves. So to understand this time progression a little more closely, we can start all the way at the very beginning to 3.8 billion years ago. So this is when the first cells, the smallest unit of life that we recognize, started to appear. Obviously not as simple as this fourth grade rendition, but it'll do for this purpose. So this form of life shows the very, very basic abilities to monitor and regulate its internal state through its organelles to supply it with energy, provide for those internal needs, and limited abilities to perceive, interact with the environment. Some cells were able to evolve very basic forms of mobility, which allowed it to move directionally for the first time, but it wasn't consciously directing its movement. It was more in terms of moving towards just its most essential needs: food, able to pass on its genetic material, and avoid dying. So an amoeba, the big old blob in the center, shows this pretty well. It's surrounded by these oval-shaped bacteria. So an amoeba has really basic mobility. It's able to sense the chemical signaling from the bacteria around it to show it that, hey, this is some food that I could use, and moving along that concentration gradient from less to more benefit. And we can see it simply engulf anything that can be seen as nutrients, and this is how it simply grows. And at the same time, it's not recognizing that it's doing this action consciously. It is just simply existing. As we continue in time, we start to see further complexity as the first multicellular organisms develop. This was around 500 to 250 million years ago when the first fish, reptiles came into existence. And while we see, more complexity in the organism itself, you can see they're still operating on pretty basic drives. So at this time, we start to see the formation of structures that eventually make up the reptilian model of the brain. We know a lot of these structures already. Our brainstem, the medulla, pons, midbrain, the thalamus, which isn't technically a part of the reptilian system, but it's a structure that developed to help coordinate all of our sensory input and to help collaborate that between older and newer structures, which we'll explore a little bit later. And then we also have the cerebellum. So with all of these structures, we finally have a concrete ability to control our primitive instinctual drives, to sustain our biological bodies, our sleep-wake cycles, gait and coordination, breathing, blinking, sexual drive, hunger cues. So accounting for all of the essentials needed to keep our physical selves alive in the environment, which is the first most important thing. And clearly this worked. Over time, this evolutionary model persisted and expanded and formed our foundation for meeting our first essential survival needs. So we don't necessarily recognize lizards or fish to name emotions, at least in the way we do in the English language, but it helps give us a starting point for the basic drives that guide animal behavior. So either reinforced through positive associations or repelled through negative ones in various nuance. So going even further in time, we start to get to 200 million years ago. And this is when we start to see the first mammals show up, where things get pretty interesting. So this is when the structures that comprise the limbic system come into existence. We understand these as our hypothalamus and pituitary, the hippocampus and amygdala. We also see the thalamus interacting with these other structures here. And what this gives us is the first formal structures to mediate information retrieval, storage, and using that information to positively deal with our environment and point us towards stimuli that is beneficial, that keeps us alive. Now, not only do these structures help consolidate this information in more complex ways, but it also still interconnects with the reptilian structures in our brains. So we now have emotional significance reinforcing the physiological drives that inform our body, fight or flight, other cues that are needed to interact with the environment. So the two biggest drives that are cemented in these structures are the fear and anxiety circuit and our circuit for reward and motivation. So our amygdala obviously plays a huge role in that by analyzing and responding to emotional stimuli, especially in terms of fear. So there were experiments done with rats where they were given unconditioned responses with an electric shock, which understandably prompts the sympathetic nervous system. They will instinctually freeze when caught in that state of fight or flight. And then they also repeated this experiment, but they would play a tone before administering the shock. So when the senses of the rat interpret these stimuli, this information goes through the thalamus. It gets shunted to the hippocampus in case there's any sort of memory that is valid with this experience to help reinforce, knowledge about the environment. And then we get to the amygdala if there's memory or a response where it procs fear. So the amygdala, at least with unconditioned fear responses, will primarily light up its central nucleus, which will then further provide downstream regulation to the hypothalamus, pituitary, regulating hormonal signaling to facilitate fight or flight. But it also does this with conditioned responses. So if an animal learns a conditioned response to fear, the basolateral nucleus of the amygdala, which is shown on the side, will actually light up, pick this up, and over time, as the behavior is reinforced, it will subsequently signal the central nucleus of the amygdala. So we're seeing conditioned responses having a closer tie to the circuitry for unconditioned responses, which just reinforces for the animal the fear and anxiety and non-beneficial behaviors that are going on. So in contrast, we see the dopaminergic system involved in many different pathways in the human brain. The one that we're going to focus on most is the mesolimbic pathway. So from the ventral tegmental area, signaling goes to the nucleus accumbens, which is our primary area for facilitating reward and motivational stimulus. It also gets shunted to the hippocampus and the amygdala to reinforce memory and emotional significance of these reward tracks. So these are the two fundamental emotional circuits that we see developing at this point in time. And this is especially important because now survival of the animal doesn't just, it doesn't focus just on the self versus the environment. It's now all about social cooperation with other organisms like itself. So another way we see operant conditioning reinforcing reward drives is through the pigeon experiments done by B.F. Skinner in the 1950s. So he was one of the first to formally study operant conditioning and its influence on reward circuitry and behavior. So he would make these things called Skinner boxes for rats and pigeons, but I think pigeons are much more interesting, where they would be conditioned to touch certain switches with their beak, and they would get food as a result if they pressed the right ones. And this was remarkably effective. You can see that they're trained to emulate this behavior in a variety of different scenarios, to the point where it almost had military significance, oddly enough. So in World War II, they had experiments where they were going to put homing pigeons in the nose of missiles to help guide the missile and make it stay on target. So the pigeon would be conditioned to recognize the specific image of the target shown on those 3 screens inside the missile. And if it poked it right in the center, it would get food. So if it was inside the missile, the pigeon would be poking on a small window at the nose of the missile to keep the missile on point. The missile would be connected to sensors that would alter the trajectory and angle of the missile depending on where the pigeon poked. So if we didn't have the advent of computer technology and electronic guiding systems, we can definitely rely on nature's computer to do the work for us. So I mentioned earlier about how at this point in time, social collaboration and cooperation is essential for survival. One of the fundamental things that young mammals have to understand is the ability to trust and accept different members of your group. Behavior has to be relatively predictable in order to not be perceived as a threat. And if an organism is able to trust its environment, it knows it can rely on it for sustenance, for its most basic physiological needs. So Harry Harlow in the 50s showed this through the wire monkey mother models. So we would have young monkeys exposed to two different models of a mother. So a very simple one with wire mesh that also had a bottle of milk attached to it that wasn't very comfortable. And another model that was wrapped in a towel. So it was soft, it was warm, but it didn't have any food attached to it. So what they noticed is that even though occasionally the young monkeys would go back to the wire mom to get fed, they would preferentially want to spend time on the towel mother. It was able to understand that, being able to trust your parent is essential for feeling nurtured. And at that point, physical touch is an essential way that this is reinforced in mammals as well. So if you're able to stay close to a member of your group, you know that it's going to help provide for you and subsequently you for it. So it shows at this point in complexity, we've established that nature can meet its most basic needs to sustain its body. So we have more complex organisms evolving on top of that. And now social cooperation is the fundamental way that these social beings meet those physiological needs. So as an organism ages, this is also reinforced through the play drive, which is a well-preserved circuit in animals and humans as well. We see our mesolimbic dopamine pathway and the nucleus accumbens lighting up in certain experiments when observing lab animals engaging in play with each other. So growing up in a safer social environment, it's almost like you have a mini tutorial to dealing with the world. You're able to practice different survival techniques. You're also able to explore different social situations and learn how interacting with your peers or others like you in beneficial or not beneficial ways influences your environment. So we can see this in the magpies here, playing with each other. We can also see this in the lion cub practicing how to pounce in front of its mother and how it reacts scared, even though, it's a cub, it didn't do a great job, but it's reinforcing that is beneficial behavior and to keep practicing those skills. We also see social cohesion reinforced through group conflict. After all, we're still dealing with individual animals trying to cooperate together while they're trying to look out for number one in terms of getting the best food, the best mating privileges, things like that. So we'll see animals literally butting heads through dominance displays, posturing, like we see in the hierarchy of wolf packs with these rams. And we'll also see it when other group members are in distress. Others in the group will go to help that individual without direct benefit to themselves. They're going to be indirectly benefiting. And these are important behaviors to reinforce because social cooperation is the name of the game. If you have conflicts with your peers and you end up just going to kill each other, like we did earlier on with life, you're going to end up with less number of people to interact with, less members of your group to help you survive. And that's very detrimental. You're not going to stay alive for long if you do that. So the fact that social conflict is still present, but cohesion and solidarity are reinforced is pretty significant. So at this point, clearly this method of evolution and lifestyle works very well. They've been able to sustain and fulfill their physiological needs and be able to keep themselves safe in the environment. And now, building on top of that, that largely depends on social cohesion, cooperation, how an organism sees itself within the context of the group. So we see how those different emotional drives are now more nuanced and expanded now that the environment you're interacting with is larger, because you're interacting with more beings like yourself and other motivations too. So further on in time, we now get to the development of our neocortex. About 6 million years ago, our line phylogenetically split from that of the great apes. And then about 2.8 million years ago, we finally got to see the first Homo sapiens. So our neocortex is what allows us to be pretty special in how we interact with the world. We have better abilities to finally control our motor and sensory input. We're finally able to have self-awareness and internal reflection on ourselves as distinct beings. We're able to have abstraction and critical thinking in how we consider different problems. And most importantly, we now have the ability for really complex language, how we express our needs and information to others like ourselves, conceptualize the world outside of the present, and really allow for the large-scale cooperation that's made us so successful, honestly. So at this point in time, we see this at work with how to abstract generalizations from the environment and use objects for reasons outside of their natural use. So this orangutan is taking a stick to, break open some food, and it looks like teaching others around it, but it's not going to look for that specific stick afterwards. It's going to maybe associate any stick or anything that looks like that as, oh, this is a food getter. This is something that can help me. And you can abstract that to many different objects as well, like sunglasses. So we've even realized how different structures, older and newer, in the evolutionary lineup still continue to interact together to sustain different modes of thinking and switching between those. I'll mention one example on this chart here, the default mode network, which is primarily involved when we go into a state of self-reflection, daydreaming. So at the peak of all of this, we have succeeded in reaching the top of the pyramid. No surprise, since this model was made with human consciousness in mind. But we see how, with being able to provide for ourselves, from a more biological concept to further up in social concept, we're able to evolve to a point where now we're able to extract further information from our environment, understand it better, use it in more abstract ways to make our modern society, essentially. And all of this has taken a relatively short amount of time. which we should give ourselves a pat on the back. As the complexity of our civilization and conscious experience has increased, the intervals of time needed to reach each point have become gradually less and less. It's a pretty exponential rise. But it's also important to understand how much of a drop in the bucket our progress is compared to the rest of, history, our time here on Earth. It's tiny, tiny, tiny. And over that time, we have done a lot to improve our surroundings and cater life to ourselves. We've been able to make advancements in medicine to understand our bodies, preserve the structures that are there, and get rid of different organisms, diseases that can harm us. We were able to construct simple machines through our abstract understanding of the world, which then led to more and more complexity to now we can drive, we can fly, crazy. We're able to promote agriculture and bring sustenance to us. And our communication, like I said before, has greatly improved from very simple, signals to the global connectivity and complexity that comes with it. This, what's important to us, not just our survival needs, but the ways we express ourselves within our communities, within ourselves, are also illustrated in our culture, how we've abstracted our ways of showing our emotions into different forms. So we see this throughout history in art. This is actually a real art installation at the Cleveland Art Museum. We see this through the development of musical instruments and the creation of music itself. And we even see this in our morals, in our concepts that through religion, through philosophy, which, are ideals, although those may change over time. But actually, like the Greek pantheon, it helps illustrate how our culture is molded based on our own conscious experience. So each of the gods in the pantheon have their own specific attributes and traits that they're known for. And these are all traits that we understand within the context of our own experience. And there's something that we consider very highly in further understanding ourselves. Despite that, though, we still have a lot of issues on our plate in terms of interacting with the world and interacting with each other. Our actions have had the consequences of causing worldwide pollution, continued war, more division with the occasional genocide, unfortunately, and huge wealth disparity. There's actually been studies where people were given false information on how their level of income compared to others similar to themselves, so similar jobs, similar socioeconomic status. And when people were given false data of whether their income was comparatively higher than the average or comparatively less, and then afterwards had them complete a mood scale questionnaire on if they felt angry or frustrated, there was a statistically significant increase in aggression in the people who perceive themselves as lower than average in wealth equality. So these are all things that we really need to fix and have been affecting our ability to cooperate even earlier in history. These aren't new things. So in '92, Robert Dunbar, who's an anthropologist, did studies on the relative size of the neocortex compared to total brain volume in different primates, including humans. And this led to the creation of Dunbar's number. This is the theoretical number of intimate relationships one person can reasonably have in their environment, just depending on that relative size of their neocortex. So this makes a lot of sense when our global community was much, much smaller and more local, where the people you knew were in the same general vicinity. But now we are dealing with a community of 8 billion people now. That is a huge discrepancy compared to where biologically we're technically at. And in the expansion of our global community to include so many different opinions on how to live, expressions of self, different topics that cause discord, it's much harder for us to reconcile with each other and cooperate when we're now dealing with so many other different, variables. So one of the ways that we see this shown is how, people perceive, slights when they're dealing with each other, how they want to feel that they have a fair chance in decision making with each other, that they're getting theirs essentially. And one of the ways that we see this is through the ultimatum game. So there's an experiment where you had two people playing a theoretical game. One person, the first person, was a proposer who would have a certain amount of money given to them, let's say $100, and they would have to make an offer to the other person who's the acceptor. So their offer would be on how to split up the money between the two of them. And he could choose any division, even like $99 to 1. But the limiting factor here is that the second person, the acceptor, has to accept the condition of splitting the money before anyone gets any amount of money. If the acceptor rejects the offer, no one gets anything. So if we're to look at this in terms of economics and game theory, there's a concept called rational maximization, where technically, if we were operating logically, the acceptor would always have a net gain of money, regardless of the decision they accepted. Even if it was like $0 to $1, it's still a net gain that is a benefit. You should take that. But we don't see this happening, especially in our interactions with each other. The research showed that the amygdala, actually, when these decisions were going on, would light up in the acceptors more when they perceived the trade-off as unfair. And that actually happened statistically significantly at offers that were at or less than 30%. The rate of highest acceptance was actually between 40 and 50%. So the importance of needing to have fair interactions with each other, significantly colors if we feel like those actions to collaborate are worth it to us in the long run. In terms of gambling, we also get a lot of reward and motivation through, our dopamine circuits with ensuring that we get our fair shake too. And this doesn't depend on the magnitude of the reward that we're going to get. It's honestly about the perceived increase of getting the reward compared to where you're at currently right now. So they measured this in monkeys at Cambridge. Wolfram Schultz led a lot of these experiments where monkeys were conditioned to press a lever to get a certain amount of food. They would first measure the amount their nucleus accumbens lit up. If they got 2 pieces of food between 20, so obviously you would see an increase in dopamine excretion with getting more of the goal. Then they measured how much it lit up when they changed the numbers the monkeys got from 4 to 40. So at first, obviously, you're going to see an increase since you're getting a net gain more from 20 to 40. But as the pattern of just getting between 4 and 40 continued, the nucleus accumbens actually, the amount of dopamine excreted decreased, and it was actually relatively the same as it was between the choice between 2 and 20. So we see that, the relative increase in a perceived reward is important for reinforcing our motivation drive. But our brains are consistently, remeasuring the environment and resetting what that baseline reward setting is. If our setting changes, we don't want to be still operating on, old reward drives. It wouldn't be conducive to adapting to the environment. In humans too, if there was a card game experiment where you still have two people, and one person is shown cheating, the other person, if they have a series of choices they can make, so one, either say nothing and let them cheat essentially, or 2 and 3, you can choose to call out the person by either one, calling them out verbally and personally taking part of their money, or doing it more equitably, where you would pay a small amount of your money to take a bit of a larger part of theirs in return. So people preferentially want fairness, and if they see someone cheating, they are going to call it out and make things more equitable for them. But it also depended on how much, resources the person had. If they had a lot of money to spend, where they could spend some of their money to get money, they would prefer to do that. That's pretty equitable. But if they were low on resources and the other person is cheating, no, I'm going to take what's mine. I'm going to override the social implications of calling you out. So those intrinsic drives wanting to reward behavior and punish bad behavior are still unconsciously reinforced in our social interactions with others. So not only this, but our cultural memory also carries emotional significance with how we interact with others we perceive differently from ourselves. So there are various studies done on American test subjects where they would show different faces of different ethnic groups very, very quickly, like in milliseconds. And it showed that our brain is very, very good at recognizing, patterns of people with different racial features, skin color, things like that, compared to people of our own race. And then, especially in terms of our cultural memory, we can see how more detrimental beliefs like racism, sexism, can be co-opted into some of the fear response that we intrinsically have. So for example, another group of American subjects were shown different faces of people of various ethnic backgrounds, and they would either be neutral faces, so just not smiling or frowning or anything, or positive smiling. And they noticed that the people's amygdala would light up more when perceiving the neutral face. They perceived it as aggressive. So even if it's not something we consciously think about, and especially with how connected we are now and overcoming a lot more of those baser divisions, it's still something that colors our subjective experience, even if it's detrimental now. So Erik Erikson in the 1960s illustrated the concept of pseudo-speciation, or essentially in easier terms, us versus them. And this describes the way that people, especially, we like to divide people into certain categories based on, cultural differences, etc., to the point where we almost perceive people socially as different beings. We're much less inclined to socially cooperate with them. And we see this in a lot of different ways today. We see it with the troubles between religion, sports teams. Identity with sports teams is one of them, where it can be, positive, enforcing collaboration and camaraderie, or promoting chaos. Racism, definitely, like we said before, political parties and political affiliation, even on a large scale, how we define ourselves in terms of nations, the borders we subjectively draw between land masses to, illustrate what our identity is, or even small things like if you prefer pineapple on pizza or not. So we understand that a lot of these divisions, even though they haven't been present for, well, they have been present for a long time in our history, but we're able to understand that, well, they can be pretty irrational. So how are we moderating that, intrinsic response? So our neocortex is really helpful in this through our dorsolateral prefrontal cortex and our ventromedial prefrontal cortex in balancing logic and emotional significance. So the dorsolateral prefrontal cortex helps us emphasize learning, delayed gratification and planning, making sure that the decisions we make are the best for the long term, that it's for the greater good, in a sense. Monkeys who had lesions to this part of the brain, when they were set to do various tasks, either ones that had more immediate rewards and some that required delayed gratification, preferentially they would go towards tasks with immediate gratification, which feels good. It's definitely interacting with our limbic system and rewarding that behavior, but it doesn't always work in the context of further interaction with the world, especially on a greater time scale understanding of that. Our ventromedial prefrontal cortex, on the other hand, closely interacts with our amygdala, and it helps us determine whether our decisions we make resonate emotionally with us, whether the decisions that we make continue to reinforce, the emotional significance that's important to us, whether it's, cultural identity, things like that. So it'll also, tamp down responses when it recognizes that, hey, this is a decision that's really close to us emotionally, but we have to tap that down in favor of being more logical right now. So this balance between the head and heart is an essential part of how we add more nuance and complexity to our abstract understandings of interacting with people, trying to cooperate in a hugely abstracted world. Even though this push and pull can be pretty, it can be pretty significant sometimes. So now that we've reached our neocortex, we see all of the emotional nuance that comes with interacting with a huge global community on this abstracted scale in the context of societal constructs that we've essentially made up for ourselves to help bring order to our lives. And it's not easy to find, a common ground between everyone when we're all motivated by different things, different drives. And we have to understand part of our difficulty with this is because, again, like I said, our development on a universal time scale is so tiny. we've only had our neocortex for a tiny drop of time. And with our abilities to abstract and think critically, we've exceeded our biological limits with, being able to cope with the world and our community associations on that level. We're pretty much like hormonal teenagers. So just the same, like teenagers have to develop their prefrontal cortex to become functional, competent adults, we can also do that as well by using our neocortex to further accept, understand our emotional drives, and moderate our decision-making to make it more inclusive. So one of the best ways that's been explored is through the work of Carl Rogers, who was a psychotherapist in the 50s and a really big pioneer of person-focused therapy, where you're focusing on increasing a person's self-awareness of their own emotional state, of the circumstances around them, of their interactions between the environment and the social environment, and increasing acceptance of all of those conflicting things. And in accepting that to, enhance further collaboration with other people, it becomes a positive reinforcement of collaborating instead of being shunted back to more primitive drives. Another way that we see this is honestly through our way to argue, to debate, to discuss different conflicting opinions, and to ideally find common ground, although our media would show us that's not exactly the case today. The way that we see debate on TV is mainly very us versus them. I don't like your opinion, so I'm going to squash your opinion so I can feel better about myself. And that's not great. It's pushing us backwards. So a really nice way, a nice example that shows how to argue with someone constructively was by Dan Shapiro. He works at Harvard at the head of the negotiations organization there. And he has a really good video that I put the link to up there. But very briefly, he goes over how important it is to identify the different points of each person's argument, what you're trying to accomplish, how to appreciate both sides' opinion, and that, these are valid points that are driving my viewpoint, essentially. And then overall taking those and learning how to collaborate with someone, how to take the argument from you versus me to, this is clearly something we both care about. How can we work together to find a collective solution? So I really like this. So overall, our emotional drives are, whether they're very simple or very complex in working together and trying to compromise, they still hold a lot of significance in our subjective experience, even if it is quite stressful. But overall, in helping collaborate with each other, we can help ourselves adapt to the abstracted world we've built around ourselves, and how to make our choices the most net positive for the future. And to finish off, I just like to play this short clip from Dead Poet Society. I think it does a beautiful job of illustrating the forces in our emotions that, drive us to stay alive, and how our language, our ability to communicate, allows that to persist and add on to itself.
No matter what anybody tells you, Words and ideas can change the world. I see that look at Mr. Pitt's eye, like 19th century literature has nothing to do with going to business school or medical school, right? Maybe. Mr. Hopkins, you may agree with them, thinking, yes, we should simply study our Mr. Pritchard and learn our rhyme and meter and go quietly about the business of achieving other ambitions. Secret for you. I'd love it. I'd love it. We don't read and write poetry because it's cute. We read and write poetry because we are members of the human race, and the human race is filled with passion. And medicine, law, business, engineering, these are noble pursuits and necessary to sustain life. But poetry, beauty, romance, love, these are what we stay alive for. The quote from Whitman, "Oh me, O life of the questions of these recurring, of the endless trains of the faithless, of cities filled with the foolish, what good amid these, O me, O life?" Answer, that you are here, that life exists and identity, that the powerful play goes on and you may contribute a verse. That the powerful play goes on and you may contribute a verse. What will your verse be?
But that essentially is the end of my presentation. I really appreciate your attention. This is a topic that I've really enjoyed for a while. This is a topic that's been really near and dear to my heart, even before I was able to properly, learn more about the neurobiology and behavioral, modification that goes behind it. 1 hour can't encompass all of the nuance behind this topic. So if you're interested in learning more, Behave, The Biology of Humans at Our Best and Worst by Robert Sapolsky is really, really excellent, and 10 out of 10 would recommend. Right.
Hey, Kathryn, can you hear me?
Yeah, I can hear you, Ariel. Hello.
Hey, that was fantastic. That was super interesting. Thank you so much for teaching us about something that we really don't, talk much about in our, formal psychiatry education. I was interested because this is obviously like the evolution of emotion is really interesting to learn about. And I wonder if you having been interested in this topic for a long time, how it informs or shapes your practice, either in treatments that you recommend or just the mechanics of how you interact with patients.
Oh, I really like that. That's good. I think it helps gives a better understanding of why we feel the way we feel, especially in the complexity of modern society where we're interacting so much on so many different interconnecting levels that it's hard for us to understand or feel like we have any control over the vast, huge emotional swings that shape our lives and what they're exactly tied to. So helping understand how they developed and why they're still around, I think it definitely helps give appreciation for how they still manage to shape our modern perspective and our modern consciousness. And I think it helps in terms of empathy for a patient as well, that we're all still undergoing the same different sways in our emotions and in how we behave. So I would say that.
Yeah, thank you. I appreciate you sharing that. I guess does your understanding of emotional, or like the evolution of emotion and cognition, I guess, do you use that in your psychoeducation, and what do you tell patients about it if you do?
You know, how we feel about the world, as nuanced as it can be, is pointing us towards things that are important to us, whether it helps us, survive on the most basic biological level, or just, interacting and surviving in our social context and what our role and identity in that looks like. So helping understand the foundation of where those feelings might be coming from I feel like it can help patients become more introspective into why they do the things they do and just increase awareness. And I think that really helps with the work that you're doing as a therapist.
Hi, Kathryn. Excellent talk. I really enjoyed it. I think it's for me it's like the experience is like going to church, sort of like I sometimes I don't understand what you're talking about, but I really enjoy hearing this kind of stuff. And then so I really appreciate you're trying to incorporate, like neuroscience, cognitive neuroscience, comparative biology, into what we're doing here. So, but with all this, extensive background, how does DSM look? Sort of like, does it look really pale or meager compared to whatever you're presenting so far? Sort of how it's just similar to Reski's question, Ariel's question. Sort of, when knowing all this, how do we apply it in our practice? Is DSM enough? Sort of, if DSM is not enough, what can we do in addition?
Well, it sounds like from the question, there's already the answer to that, which it's a gross oversimplification. I think the DSM is a great way to help categorize at least the different ways we subjectively see different forms of mental illness and how, people can react compared to, just baseline feeling okay and feeling like a member of the community. So I feel like the DSM, understanding mental illness and what it is in that sense is still important, but to help build on that, understanding the nuance, the gray area in why we feel the way we feel, I think is important too. The DSM, it's good to have things in black and white to help conceptualize and organize, but it doesn't do much justice to the gray area that we're constantly living in when we're making these decisions.
So another thing is like, what's the difference between arguing and psychotherapy? Sort of, you review this thing, how to argue, and then how would you apply that in your psychotherapy?
I feel like nowadays the term arguing, it's very polarizing and it has a primarily negative connotation. So it makes people almost afraid to argue and debate and, like take the points that you're making together and find out something more.
But if we stop talking, we're just going to start have wars. What are we going to do? We still have to talk to each other. Is that right?
Right. It's a hard question to answer. I think we all find ways to.
No, I really enjoyed it. It's an excellent talk. I really enjoyed it.
I just had more of a comment. Can you hear me okay?
Yeah, hi Megan.
Hi. So I thought it was just kind of ironic that this was the topic of your talk, because the second years had just been reading that Freud and Beyond book, and it reminded me of the difference between Freud and how there's two primitive things like libido and aggression that drive us, but then Hartman, I don't know, I'm sorry if I'm repeating stuff that you already know, but Heinz Hartman, how he thought that actually it wasn't about pleasure seeking like fantasies really, but it was like built in like potentials waiting for like the environment to shape them basically. And I just think that it's interesting how kind of like basically we created this environment that I guess you would assume is like the ideal like place for our, I guess, impulses to be carried out in like a way that's acceptable to us. But then it just like kind of makes you think like, you know, what if the environment like was different? Like, because all this stuff technically is just kind of like made up by us, but like by the neuroanatomy of it, that like it is kind of like, you know, it's already there, it's just waiting. I don't know, sorry if that makes no sense. It's like
No,
really
it makes total sense. That's actually like the whole like brain awesome like cool cloud that I had in my mind that really made me interested in doing this talk, because we did essentially create the best and worst of ourselves. I mean, not on purpose, obviously. All of the improvements we've made to society and the way we interact now was to help make our survival easier. And so, we weren't dying by the age of 25 thanks to a woolly mammoth. But, with the complexity that comes with, building a more abstract and, bigger global community, come, making the concepts of like our modern society, culture, even currency, concepts of, religion, even, they're concepts that don't exist in the natural world, but we make them real. So while they bring us together, they're also, things that we have very strong opinions about. They're still dividing us. And now that we have the ability to cognitively like think back and reflect on how ironic that is, it's about high time that we actually started working with that awareness and using it to, propel our collaboration to something that's more cohesive.
But is like the environment like somehow that we created serves like some kind of purpose for us? Like there was like a reasoning behind it. So it's just kind of like, I don't know, it's really existential.
I know, that's my favorite part about it.
But thanks for the good presentation.
Oh, thank you, Megan.
Kathryn, great presentation. Thank you. The topic, I think, a great choice of topic. From that existential talk, a little bit oversimplification. I just had a comment to share. I think a presentation reminded me of my child fellowship, where in therapy, sometimes we'll begin, one of the basic things we'll start off with is emotional identification. So we'll show the wheel and the kid has to just choose the emotion. So something as fundamental as that. So it just reminded me how that is the fundamental of when we start the therapy with kids. And then your comment about how we argue. So I think that also comes in our therapy. We talk about conflict resolution and then using I statements that I feel this, and that's how you communicate is a huge part of how to resolve conflicts. Just wanted to share that it's a huge part of therapy with kids.
I mean, if this is something foundational we're teaching to our children, I think we can definitely expand on it.
Right. Well, thank you. Great topic.
Dr. Rabbani, are you wanting to ask a question?
Yes, yes, I do.
Oh, go ahead.
Okay, my question is a difficult question, but I really appreciate this topic and the way you discussed it. It was great, amazing, really. I can say two questions. One is that this evolution of emotions, how it has happened. I mean, the biologic changes happened and made us, made the emotions change, or our thinking, our human beings made those biological changes in brain and made that evolution happen. I wonder if you know about this or not. And my second question is that with this evolution of human beings in general, physically, we have used our intelligence to change the physical world a lot. But the spiritual part is getting lower and lower. I mean, we are using this intelligence to make our nation stronger, to be more aggressive in a sophisticated way, and this and that. So where are we going? How are we going to change that? I mean, I wonder, you may not be able to kind of answer this, but we as human beings, we should think that way also, that we are all cells of one body. Like our body with different cells, each part is doing a different thing, but to make our body better is each cell to work is work the right way and the good way. How are we going to learn this? Then the world is going to become the right world.
I think those are honestly the big questions. Well, in terms of your first question, I think the interplay between our behavior in the environment and the environment shaping us, I feel like it goes both ways. I mean, at the point where we were able to evolve, to mammals, to be able to actually socially connect and cooperate with each other instead of having it all out just for ourselves, it complexified a lot of those survival drives. It wasn't as clean cut anymore because now you have to rely on so many other people and so many other opinions and motivations to get yours. You have to work together in order to allow for your own survival. So it clearly has helped. Obviously, through evolution, it's stuck around because it works with the modern world. And I think this ties into your second question. Just to remind myself, the second question you mentioned is like, where do we go from here? Is that right?
Mm-hmm. Yes. Mm-hmm.
Oh God, I don't know. I mean, the thing
are we
is,
going to get worse, or we are going to finally understand that we should be all cooperate with each other better and not to be aggressive toward each other and this and that. So
it has to be something we all collectively agree on. I think we understand, at least to some point, that we've clearly gotten to a really good place for ourselves and building up the world so that we want for nothing. But it's a lot easier to build concrete things for yourself instead of turning inward and trying to reconcile all of the messy ways we divide each other, honestly. So I think it comes with a bit of, well, not just self-awareness, but some humility as well, that we can, we can cooperate with people that we may not agree with, and to work above that instead of capitalizing on the basic drive of I won, you lost, get over it.
Yes, thank you.
I would just want to make one more comment, kind of like taking into account everything that we've talked about. Just, it would be really interesting to fast forward 6 million years, assuming that there were some sort of evolutionary pressure to direct cognitive and emotional development a certain direction. It would be very interesting to see how we evolved as a species.
That would be really fascinating, because you need that pressure to positively select it so that it keeps going. So it keeps persisting. So what is that going to look like for us?
I mean,
constantly push it for ourselves.
right. It's hard to say what evolution actually looks like nowadays because there doesn't seem to be all that many, especially in the West and in developed countries, too many things that provide consistent like survival, confer consistent survival benefits. So I think we don't necessarily select for any particular traits at this point because all sorts of people are surviving. So it's really more about who's reproducing the most. But if there were any survival pressure in any direction, it'd be interesting to see how we evolved emotionally and cognitively. It's an impossible question to answer, but it's just interesting to think about.
It really is. Oh man, that could spur like a whole other talk.
Are there any other questions among the panelists or the attendees? Doesn't look like it. Thank you so much, Kathryn. This was absolutely fantastic.
Thank you.
Well done presentation and generated a really interesting conversation. Davis, if you can correct me if I'm wrong, but I do believe that we have RAC after this.
That is correct.
All right. So we will meet in Davis's Zoom room.